Right, so we're trying to find what times what is 63. So we're going to say 7 times 9, 63. And then you can say this. 7 is prime, so we like that, but root 9 to get 3. And there's your answer. Right, truncating numbers is a nonsense, but there we are. So the number is y. Whenever you're truncating or doing upper bounds or lower bounds, your inequality symbols will always be like this. Now we're truncating, it's allowed to go up to 2.8 almost. I can go all the way down to 2.7. So any number that's been truncated with an answer of 2.7 could be anything from 2.7 all the way up to 2.799999999. Okay, so it's different to error bounds. If you were doing upper and lower bounds, you would have something like this. Okay, which makes more sense to me, but this is truncating, so this is the answer. If it was upper or lower bounds, then this would be your answer. So we're factorising. So what times what would give me 3y squared? And what times what gives me 3? So I'm looking at this. What times what gives me this number? Often I just jot them on the side. So I've got to try and make the middle number 10, but I do have a 3 here. So if I do 3 3s are 9, plus the 1 to give me 10. So the 3 would need to be there, and the 1 would be here. Now the middle number is negative, but this is positive. And that kind of tells me it's got to be that. I would always re-expand to check. So front times front gives me that. Back times back gives me that positive 3, and then minus a y, and then minus 9y to give me the minus 10y. Alright, let's just imagine we were to draw this. So this has got an intercept of minus 5. Okay, and a gradient of 2. So forward 1, up 2, forward 1, up 2. So it kind of looks like this. So that's that line, and then I want to find out where it crosses the y equals x line. So, alright, so that's the point I'm after. Now this question really, I mean, you could draw it and try and do it accurately, but that's not the way it's designed. This is a simultaneous equation question. So you can see they both equal y, so you set them equal to each other. Okay, because they both equal y, they must equal each other. Then just solve it. So let's take x from both sides. Well, what times 5 equals 0? Must be 5. So that's one solution. And it's y equals x, so the other solution must be the same. That's my other one. Okay. Now you could do this with a tree diagram, but it isn't really necessary because you've got the same number of sweets of each colour, and also when a sweet is taken out, it is replaced. So it's actually a straightforward one. So I'm going to say that the probability of a yellow is 6 out of 12, or a half, and the probability of a blue, 6 out of 12, also a half, and we want to have at least one blue. So in other words, you want to have blue blue, or blue yellow, or yellow blue. So these are your options. So blue blue, well this is blue and blue. So and means times, so it's half times half. Blue and yellow, so that's probability of blue times probability of yellow, so again that's half times half. And yellow and blue must be the same, half times half. Work those out, add them all together, and that's your answer. So half times half is a quarter, and you've got another quarter, and another quarter. So altogether gives you 3 quarters, which is your answer. Now the fast way to do that is to do the opposite and say what's the chance of having no blues? Well, the chance of having no blues is yellow and yellow, and the probability of a yellow and yellow is a quarter, and then you take that away from 1 to give you 3 quarters. Okay, I hope that was okay. If it wasn't, you know what to do.